This vehicle is, from the bottom up, designed with collaboration with scientists, external peers and whatnot. We've taken their input and now kind of applied it to existing technology as well as anything else we could develop for any innovation that we'd want to incorporate into the vehicle. This is our second science cruise for SuBastian, and now we've done a bunch of upgrades. We've did a rebuild on the vehicle for the last 8 months or so, and it's all shallow water operations, so 100 to 200 meters, which is a completely different setup as far as how the ROV needs to be positioned, how the ship needs to maneuver, and basically how the ROV has to operate in these kind of waters. But in general, everything has been going really well. Our first cruise at depth went really well, and now this cruise at shallow water so far, knock on wood, is going really well.
Our overall goal is to be able to date sea level change from 20,000 years ago to about 10,000 years ago, and in order to do that, we have to have samples.
The front tray, the front working area of the vehicle, is usually used for crates for samples that we can divide, and they can put various samples in that.
Most of these were collected a little under 100 meters. They should be close to about 12,000 years old. The reason we do all the cleaning steps is because when you pull something off the seafloor, it smells really fishy. So in order to keep down that smell and make sure our samples will mold within the process of taking them from the ship back to our lab, we have to scrub off all the algae, all the living material that has been on them. After that, we take them to a saw and we cut them in half, because a lot of these corals, unless there is a broken face, we're not able to see if there is actually coral inside. Sometimes it's just calcareous sand or calcareous micrite. They're not actually corals.
Yeah, flying an ROV is very similar to flying a plane. That's why I think they're called pilots. But yeah, they're just constantly looking at their depths, the navigation feeds, the altitude above bottom, the sonars. We have 2 sonars on the vehicle, so you're constantly looking, 50 to 100 meters ahead of you using the sonars.
The main new system that we brought with us is, we call it a photomosaicing system. So it's a new sled that fits in the underside of the ROV, and it carries a pair of strobe lights and a pair of stereographic imaging cameras. So these cameras are pointed directly down at the seafloor. We call them bathymetric imaging cameras, and we use them to prepare a photomosaic, which is stitching together of a series of photos so that we can prepare one large image showing an area of the seafloor. This cruise, we're also deploying a new annotation system that the scientists are using on board. So this system is called Squid.
Squid Plus is an online tool for managing, analyzing and exploring marine annotation data. We've just introduced a real-time annotation tool on board the ship during live ROV ops. So that gives scientists the ability to use the same standardized annotation tools with a quick real-time interface that they can log events and also tag images and frames in real time.
It's always good to go out to sea with another chief scientist to learn, tricks of the trade and what kind of things they like to incorporate in the future, not just for the cruise that you're on, but also for the future cruises, so that we can always continue to improve on the vehicle. So yeah, so definitely it makes a difference to be out at sea with and working side by side with them.